So here we have a function of two variables, f of xy equals to 1 over square root of x squared plus y squared minus 16. And we would like to determine all the points xy for which this formula makes sense. That's what we call the domain of definition of the function. And in general, there are two possibilities. Either the domain of definition will come with a function, so a set will be given to us telling us what the set on which the function is defined, or it would be up to us to determine what are the points that we can plug in for which the formula of the function makes sense. And of course, when we have such considerations, we should make sure that the usual algebraic quantities that show up in the formula of the function are meaningful. So here, what do we want? We have a denominator. It should not be 0. But more importantly, we have a square root. So the content of a square root should be greater than or equal to 0. Exactly because it's on the denominator, it should be strictly positive. So in general, we will say, so quantities under a radical. So these are the general principles. Should be greater than or equal to 0. Denominators should be different from 0. And we might add to it quantities inside ln should be positive. And when I say that, when I say quantity inside an ln, I mean the whole thing. So this is what I mean, the quantity, not in individual components. Same thing for here. I want x squared plus y squared minus 16 to be positive. I don't want x to be positive or y to be positive. So after these remarks, let's give the solution. So the domain of definition is all xy's such that x squared plus y squared minus 16. So like I said, in the case of a radical, we want this to be greater than or equal to 0, but because it's on the denominator, we will ask for more. We will ask that this is greater than 0. And then the next question, since the problem is asking to sketch, is can we figure out what this set is? And we start by the fact that if we take equality here, so if we take x squared plus y squared minus 16 equals 0, meaning x squared plus y squared equals 16, this is a circle of radius 4 centered at 0. So it cuts here at 4, at -4, and so on. And the reason I'm representing this in a dotted way is because the circle itself does not belong, is not a part of the domain of definition. And once we sketch the circle, it divides the plane into two parts, the exterior and the interior. And the question is, which one is the part that actually on which the function is defined, which is defined by the inequality we like. And for that, we can take a testing point. So for example, if you take 0, 0, the origin, you will see that it doesn't check out, meaning if we plug it in, we get -16, which is not greater than 0. That means that the part that has 0, 0 in it is not what we're looking for. So what are we looking for? The other part, which means the exterior. So now we're able to actually sketch the domain of definition, and it's exactly this one without the boundary. So that's the set on which this function is defined. Thanks for watching.